Welcome back to All This Math. Please, if you're here, go ahead and hit the like button. Make sure you subscribe if you're not subscribed already. If you have any questions or comments as I proceed through the explanation of this problem behind us, please don't hesitate to put your comments or questions about what I'm doing in the comment section. All right. And also, please share this video with at least one other person. All right. Also, I do want to give a shout out to the brother that's on my shirt, Omawale Malcolm X, also known as Malcolm X, also known as El Haj Malik Al Shabazz. As I record this video in May of 2025, we are getting close to the 100th anniversary of this brother's birth. So I definitely want you to, refamiliarize yourself or further familiarize yourself with this brother, this ancestor, and his work. I highly recommend three speeches. He had more, made of course far more than three speeches, but I highly recommend these three. Ballad or the Bullet. He dropped that in 1964. Message to the Grassroots. I believe he dropped that in 1963. And The Last Message, which was in 1965, a week before his assassination at the Audubon Ballroom in Harlem, New York. So I highly recommend those three speeches. Also, of course, if you haven't already, read his autobiography, The Autobiography of Malcolm X, as told to Alex Haley, right? If you have read it, give it a reread. It's going to be different. Every time you read it, it's going to be different at a different stage in your life, right? Because you have different life experience, right? So the book will be totally different, you know? And also there are a host of other biographical accounts, on the life of Malcolm X and the work of Malcolm X as well for you to, get into as well. Now, with that being said, let's get into this problem. What are we doing? We are multiplying rational expressions. How do we know we're multiplying? Because of this multiplication sign right here. This dot is also a multiplication sign. Usually you see the X or parentheses can represent multiplication, but this dot also represents multiplication. What is a rational expression? A rational expression is another way to say fraction. It's kind of like a more fancy way to say fraction. All right. Numerator, denominator. Numerator, denominator. Right? Sometimes the denominator and numerator is just a single digit. Sometimes you got a trinomial, a whole quadratic trinomial. Why is it quadratic? Because the biggest exponent that had any of these terms has is a 2. Right? This is a quadratic, but this is a binomial because it's only got two terms. 1, 2, 1, 2. Terms are separated by plus signs and minus signs. Plus signs and minus signs. So this is one term, this is one term. 1, 2, 3, 3 terms. 1, 2, 3, 3 terms. 1, 2, 3, 3 terms. Terms are separated by plus signs and minus signs. It's quadratic if the biggest exponent you see is a 2. This is a quadratic trinomial. This is a quadratic trinomial. Like I said, that's a quadratic trinomial. This is a quadratic binomial. All right. Now, when you encounter problems like this, what you do is you try to factor them. You look for things you can cancel out. Ain't none of these the same. None of these have exactly the same terms in them, right? So you can't immediately cancel nothing out or divide anything out, right? But if you factor, right, and factor into something, if you're in an algebra class, or if you already took an algebra class, you need to know how to factor. You got to know how to factor algebraic expressions, which is what these are. You got to know how to factor, meaning you break them down into expressions that have a lower degree. Now, the degree is indicated by the biggest exponent, right? So the degree would be, this is quadratic. The degree is 2. I think it's 2. I always get that confused. I don't know if you got to add the 2 with the 1 to make it, nah, because then that would be cubic. Nah, this is quadratic. The degree is 2. The degree is 2. Yeah, the degree is 2. Right. That's right. When you want to know the degree, you look at one term and you add up the exponents in the variables in one term. There's only one variable here, right? So that's a 2. There's a variable here, that's a 1. The biggest exponent is what constitutes what the degree is. See, I always be forgetting that. I be forgetting it, but it just came back to me just now. All right. You know what I'm saying? Must be the ancestors helping me out. That's what's up. All right. So anyway, all right, look, check this out. So we got a quadratic, but when we factor, we break them down into separate expressions that have a lower degree. So we're going from the second degree to the first degree. So we create linear expressions. So we're going to have m to the first power, and another m to the first power. That's linear. That's to the first degree. All right. Now, it's a certain way to factor quadratic trinomials. All right. Now, this is how you do it. Now we're going to factor this. 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 This is different though. This is a binomial. This is what we call a difference of two squares. Difference of two squares. So there's a specific way to factor a difference of two squares. I got a whole playlist where I just talk about how to factor differences of two squares. I got a whole playlist where I talk about how to factor expressions like this, quadratic trinomials. Where now, look at the difference between this trinomial and this trinomial, though. Look at the lead coefficient. That's math vocabulary you need to know. Lead coefficient. Like the line leader at elementary school, like the young boy or the little girl that's in front of the line, they take pride in that, right? That 2 is the lead coefficient. That 2 is the line leader. In this expression, though, it's an invisible or understood +1 that's the line leader. So you factor this and this differently. This is easier to factor because there's a 1 up front. This is more involved. I'm not going to say difficult. It ain't more difficult. It's more involved. It's more involved because it's a 2 up front. If it is any number besides 1, you got a little more work to do. It's going to be a little more involved. You know what I'm saying? Then right here, you got a 2 up front. It's a little more involved. All right. But we're going to work it out, though. Now, it's a lot of ways to factor a quadratic trinomial. One way is trial and error. What's trial and error mean? Basically, you just guess. You guess where the numbers go. I'm going to show you. When I show you, it's going to make more sense, right? So let's do this. We're going to rewrite this numerator into 2 binomials. So look what I got here. I got the parentheses right there. We're going to take the factors of 2m squared, which are just 2m and m, because 2m times m equals 2m squared. So you're going to put a 2m right here and an m right here, right? So in the first spaces, you put the factors of the first term. The factors of the first term. So I got 2m and I got m, because 2m times m is 2m squared. Now, the question is, the big question is, what's going to go in these 2 spaces? The numbers that go in these 2 spaces are this. They got to be factors of -15, right? They got to be factors of -15. But if you know anything about the FOIL method, right, that's something else that you need to be familiar with. The FOIL method. If you know anything about the FOIL method, you know that you got to put numbers here and here. Whereas if you were to multiply these 2 expressions by each other, the product would be the original trinomial you started out with. I'm going to say that again. You got to put factors of -15 in these 2 spaces in such a way where if you multiply this binomial by this binomial, right, your product would be the original trinomial you started out with. So first you got to think about this. Now, like I said, it's a lot of ways to factor quadratic trinomials. We could use something I call the Malcolm X method. Got the Malcolm X t-shirt on. I'm not going to do all that right now because the video is going to get too long, right? Because I got to factor this and I got to factor this and I still got to factor that, right? So I ain't going to spend a whole lot of time. I'm going to use the trial and error method. But I'm telling you, you just got to you can only use factors of this last number, meaning I can only use -15 and 1, or +15 and -1, or I can use -5 and 3, or I can use +5 and -3. -15 don't have a whole lot of factors, right? So we kind of got lucky. Just like 2 is a prime number. This don't have a whole lot of factors. So my only options was 2m and m. But if I'd have had like a 6m squared, then I had to play around with more numbers, right? So I don't have a lot of options dealing with 2m squared because 2 is a prime number, right? But if it was a 6m squared, I could have had 3m and 2m, or 6m and 1m, right? Or 2m and 3m, or 1m and 6m, right? See? Trial and error method, right? Like I said, it's more involved. It's more involved. So look, this is what's going to happen though. Watch this. Because I've been doing these problems for like 30 years, actually more than 30 years, like 35 years. I've been doing these problems for like 35 years. I can look at problems like this and just kind of see through some type of it's a lot of skill involved, but it's some intuition too. Just because I got a lot of experience with these problems, because there's only but so many quadratic trinomials and number combinations that they can come up with, right? And I've seen so many textbooks over the years and actually done so many of these problems. Sometimes the answer just jumps out at me, right? But what I'm gonna do is I'm gonna use -5 and +3. -5 and positive. I'm gonna put a -5 right here. Now, I said this is trial and error. I'm kind of just guessing, even though I know it's right. And I'm gonna put a +3. So I'm gonna put a +3 right there, right? So now dig this. Now, when I multiply this out, it's gonna equal this. So that's how I know that I factored it correctly. Because look, 2m, you got to multiply this 2m by both of these. Then you got to multiply this 3 by both of these. And then you got to combine like terms and see what you get. Some people call that the foil method, like aluminum foil. Like, you know what I'm saying? You go to the cookout, wrap up a plate, you know what I'm saying, for later or whatever, or take a plate home to somebody, you know, put the aluminum foil on top. Some people call it the foil method. Foil is an acronym. It stands for first, outer, inner, last. Multiply the first terms, multiply the outer terms, multiply the inner terms, multiply the last terms. Last, 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 last. All right. 2m times m is 2m squared. That's what we got right there. 2m times -5 is -10m. 3 times m is 3m. Stop right there. What's -10m plus 3m? What's -10m plus 3m? -7m. And what's 3 times -5? -15. So we good. We good. We just factored this, right? Through trial and error. Through trial and error, right? Now, if I'd have put 15 and -1 right here, it wouldn't have worked. If I'd have put 1 and -15 right here, it wouldn't have worked. That's why it's called trial and error. Trial and error. That's this particular method. It's not the only method, right? There are other methods that are more straightforward and more they guarantee you to get the answer, but they're more involved. And I ain't want to do that in this particular video. All right, now let's go down here. M squared minus 16. That's called a difference of two squares. Difference because of the subtraction sign. 2 terms, squares. This is a perfect square, m squared. This is a perfect square. 16 is a perfect square because it has a factor that can multiply by itself. Or I should say this, its square root is a whole number. The square root of 16 is 4. 4 is a whole number. Because 4 times 4 equals 16. Make sure you know what a square root is. And make sure you know what a perfect square is. I just told you what a perfect square is. A perfect square is a number whose square root is a whole number. Every number got a square root. But every square root ain't a whole number though. So this number is a perfect square because it's a little special. It's a little elite. You know what I mean? Like its square root is a whole number, 4. Just like 25 is in that category. You know what I'm saying? They some like top tier numbers. You know what I'm saying? Like 25 has a square root of 5. 5 is a whole number. 100 is a perfect square because 10 times 10 is 100. 64 is a perfect square because 8 times 8 is 64. Right? Like I said, every number has a square root. But every number ain't a perfect square though. You only a perfect square if your square root is a whole number, right? If you like that, you know what I'm saying? Some numbers is like that, some numbers ain't like that. All right. So anyway, so how we break this down is you write 2 binomials, similar to how we did up here with this, right? 2 binomials, except it's a more easier process because we know that it's a difference of 2 squares. We take the square root of the first term, which is just going to be m, because m times m is m squared. So you take the m, put the m right there and the m right there. You take the 16. The square root of 16, take the square roots, Put a 4 right here and a 4 right here. Now, what else do? You make one a plus sign and one a minus sign. Do it matter where the plus and minus sign go? Nah, it don't. As long as you got one of each. I could have put the minus sign here and the plus sign here. Why didn't I? No reason. No reason. I just felt like doing it like that. I could switch it up. You know, you're going to get the same answer anyway, right? Because if we multiply it out, no matter where the plus and minus sign is, you still going to end up with m squared minus 16. That's how you know it's factored correctly. All right, now let's go over here. M squared plus minus 6m plus 8. Another quadratic trinomial. Set him up. 2 binomials. Boom. 2 binomials. Now, because the lead coefficient is a 1, this one is even easier. It's a little lighter. Take the m squared, break him down. Put an m here and an m here, right? Because m times m is m squared. Now, with this one, because the lead coefficient is a 1, all you got to do is come up with the 2 factors of the last number that also add up to the middle number. I'll say it again. The 2 factors of the last number that also add up to the middle number. If you don't understand it, pause the video, run it back. Take it from the top, rewind it. All right. Now, what 2 factors of positive 8 add up to -6? -4 and -2. Not +4 and +2, because 4 plus 2 gives you +6. We need a -6 though, right? So -4 and -2. So I'm going to do -4 right here and -2 right here, right? Now that's factored. Now we go into the denominator. Again, quadratic trinomial, right? 2 binomials. The 2m squared, just like I had up here. I'm going to do a 2m and an m. That's easy to do because 2 is a prime number. It ain't that many options when you got a 2, right? Ain't that many options, right? But now we got to put something right there and something right there. But they got to be factors of 6. So either we working with +6 and +1, or we working with +3 and +2. 6 don't have a whole lot of factors. Just like -15 ain't have a whole lot of factors, right? But we got to put the numbers in the right place because we want to end up with an arrangement where if we multiply this out, it would equal the original trinomial, right? So dig this. What we going to do? Let me look. I'm looking at this. I'm like, Oh, I'm tripping. Yeah, let's do this. -2, -3. Here we go. -2, -3. Now, basically, here's like the trick, I guess. I don't like to use the word trick, but I can't think of a better word right now, so I'm gonna just use the word trick. We worried about the O and the I in FOIL because we want to put numbers here, here, and here that will lead to us ending up with a negative 7m as our middle term. We got to put the correct numbers in the correct places that'll lead us having a negative 7m for our middle term, right? It'll make more sense if you look into the FOIL method. That's why I like the FOIL method. A lot of teachers don't like the FOIL method. I'm a fan. I dig it. I like the FOIL method. You know what I'm saying? It's helpful to me. But to each his own or her own. Right? Now, how do I know this is right? Because if I do the FOIL method, 2m times m gives me 2m squared. That's that right there. Then the outers, 2m times negative 2 is negative 4m. The inners, like I told you, you worried about the outers and the inners, the product of the outers and the product of the inners, and add them up. And then negative 3 times m is negative 3m. What's negative 4m plus negative 3m? Again, what's negative 4m plus negative 3m? Negative 7m. That's how you know your numbers are correct and in the right place. The numbers got to be correct and they got to be in the right place. Because you can have the right numbers and have them in the wrong place. Like if I had a negative 2 right here and a negative 3 right here, this wouldn't work out. It wouldn't have worked out. The numbers got to be correct and they got to be in the right place. Right? Right place, right time. You know what I mean? That type thing. All right. Now, then we do the negative 3 times the negative 2. That's how you get the positive 6. Now, everything is factored. Now, with a problem like this, once you factor everything, that's when the fun part starts. I remember in middle school, I used to like this because now you just get the slicing and dicing. Look, so you look for terms that are the same terms, the same binomials that's on top of each other, like boom, like this right here, m minus 2 and m minus 2, cross them out. And then over here we got the then diagonal. If they vertical and they the same, cross them out. They diagonal and they the same, cross them out. Boom, I got an m minus 4 right here. I got an m minus 4 right here. Boom, they cancel out. I got what else? I got I got a 2m minus. Whoa, hold up. I think I'm getting ahead of myself. Hold up. Is this supposed to be 2m minus 3? Yeah, it's got to be. And that's 2m plus, 2m squared, negative 10m plus 3m. Okay, yeah. Oh, yeah. I was tweaking for a second. See, I was having too much fun. Like Rick James on the Chappelle Show. having too much fun. You know what I'm saying? So m minus 4s cancel out. What else cancels out? The m minus 5 don't got nothing to cancel out with. M plus 4 is left. So what we left with? I'm gonna put it right here. Equal sign. And and these are just ones, right? And so so this numerator, right, is gonna be 2m plus 3 times m minus 5 over m plus 4 times 2m minus 3, right? And that's our final answer because we can't cancel nothing else out. The m minus 5 can't cancel out with the m plus 4. Oh, let me say this too. This m and this m cannot cancel with each other or cannot divide with each other. They can't because this m is part of a binomial. It's like they're in a relationship together. Just like this m is in a relationship here, right? You know what I'm saying? We can't just go and this m can't cancel out with this m. Nah, we can't do that. We can only cancel out whole binomials. The whole m minus 4 cancels with the whole m minus 4. This whole m minus 2 cancels with this whole m minus 2, right? That's all we can do, you know? Hold up, man. You know what? See? This is what happened. I knew this was weird because I did this problem before. And this ain't the answer I got. You know what? I copied it down wrong. This was supposed to be a plus sign. If this was a plus sign, then some more stuff would have canceled out because then I would have had a 2m minus 3 right here. And then it would have canceled with this. But it's cool though. Based on what's written on the board, this is correct. This is correct based on what's written on the board. You know what I'm saying? But yeah, this video getting kind of long. It's almost 20 minutes. I might have to chop this up into little clips. You know what I'm saying? But yeah, that's the final answer. This is how you multiply rational expressions. So if you have like quadratics or cubics, you need to factor everything. Your numerators and your denominators, you got to factor everything out. That's why you learn how to factor. You learn how to factor so you can do problems like this. That's one of the reasons. The main goal is for problem solving ability. Learning how to factor is like it teaches you a systematic way of solving problems. And that's what we need in life as adults. And as adults, we need systematic ways of solving problems, right? A lot of us don't have that. And that's why we never are able to solve our problems. And that's why we be mad all the time because we got problems and we don't know what to do with. We don't know how to address our problems and how to solve our problems. We don't know. So, hey, you know what I'm saying? But yeah, factor everything, numerators, denominators, and then look for stuff to cancel out. Look for stuff to cancel out. Whatever doesn't get canceled out, that's your final answer. Just put them together. All right. And make sure you like the video. Make sure you are subscribed to the channel. Make sure you share this video with at least one other person. All right. Somebody in an Algebra 1 class or Algebra 2 class or a college algebra class on the campus somewhere. All right. And if you got any questions about anything I did, don't hesitate. Put your question in the comments. Put your comments in the comments. All right. And again, shout out to the ancestor Malcolm X. Again, May 2, 2025. This is the 100th anniversary of his birth, May 19th, 1925. All right. Peace.